manufacturing going on in this specially lit clean room is about to go mainstream. Tiny nano devices are embedded and rolling off the presses. Think of it as a great leap forward in fabrication. In the future, these new methods could bring clothing that protects soldiers from chemical weapons, or small Band-Aids that constantly monitor vital signs in real time, whether we're at work or at play.
You can have something that both performs better and is less expensive, right? That's really the heart of nano manufacturing.
With support from the National Science Foundation, University of Massachusetts Amherst chemical engineer Jim Watkins and his team at the NSF Center for Hierarchical Manufacturing are working to take nanotech from the lab bench to an industrial scale.
One of the things that the center does is it paves that road, right, from the laboratory to a manufacturable platform where industry can pick it up and use it in a real-world process to make products that people want and that people can afford.
This roll-to-roll process is already used in traditional manufacturing. But now Watkins and his team are developing methods to incorporate nanotechnologies into the process. That's of high interest to Jim Casey, who works for Flexcon, a company that manufactures labels and coatings using a roll-to-roll system.
But we are working in areas with antimicrobial surfaces, some health monitoring systems, some defense applications. The application potential is huge and the opportunities overwhelming.
It's a big job working with materials this small. Nanoparticles are about 100,000 times thinner than a human hair.
The wet film now is on the outside of this roll, travels up.
The team is working on a nano manufacturing process to make printable coatings that improve the way solar panels absorb and direct light. Watkins says they're also using a similar process to light up a room.
They can go in the windows to bend light so that you can illuminate both the top and the bottom of a room, improve your ambient lighting.
Communications is another area ripe for nano manufacturing.
We can use nanotechnology to shrink the size of an antenna for the communications. We can use nanotechnology to improve the sensitivity of the sensor.
They are also looking to use self-assembling nano products that could have applications for many industries.
We build inks that are composed of macromolecules, nanoparticles, nanotubes, nanorods. These systems will spontaneously assemble into the structure and morphology that we want on their own.
Down the line, the applications for nano-manufactured products are nearly endless. Better sensors could improve cancer imaging and make the lines at airport security dwindle away. It's all about working with industries to expand their reach into this brave, tiny new world. For Science Nation, I'm Miles O'Brien.